Hi, everyone. We're kicking off our webinar, just waiting a couple minutes for people to join. In the meantime, I just wanted to make a brief introduction here to our How to Effectively Evaluate AI Agents webinar. Just so you guys know, the webinar is going to be recorded and we'll be sharing it with you guys afterwards. And also during the webinar, feel free to ask questions on the chat as you wish, and we're gonna do our best to answer all of them as we go. And without further ado, I would like to introduce Julie and Connor, our lovely speakers, and pass it on to them so that we can get started. Julie and Connor, please welcome on stage and feel free to start.
Thanks, Barbara. Hi, everyone. Welcome to How to Effectively Evaluate AI Agents. I'm Julia Tran, joined by my colleague Connor Jensen. Today, we'll take you from the hype of demos to the reality of evaluating agents so they work reliably, safely, and at scale in your enterprise. Connor and I will share what we've learned from working with organizations deploying agents and from ongoing research into evaluation practices.
So to do just a quick level set to make sure everybody understands Dataiku as a platform, just so that you get the context of where we're coming from and how we interact with our customers in this. The way we typically describe Dataiku is it's a single platform for the development and the deployment of AI, or sort of like the full spectrum of data and AI tools across four main pillars. One, it's for everybody. It's for people who have coding backgrounds and are data scientists or AI engineers, but it's also for finance analysts, people in the business, marketing teams, things like that don't have a coding background. It's got a very sort of varied interface to be able to work with that data in different ways depending on your skill set. It allows you to connect into all of your data. Dataiku does not have a dedicated data repository within it. We're specifically designed to integrate into your existing data landscape, which means you can work flexibly across a hybrid environment in the cloud, on-prem, multi-cloud setups, et cetera. And you can access that data and work with it and leverage the investments you made in your data architecture and the power of the compute of platforms and things like that, but being able to do it without having to prerequisite that all the data has been migrated or moved or things like that. Across the technology landscape, we very much sort of future-proof you against that. I myself first used Dataiku in an on-prem Hadoop implementation, and since have used it in Azure and Snowflake and all the different places. We really are very tech agnostic, aggressively agnostic, sometimes we say. We really understand that enterprises have a huge variety of data platforms already in place and different LLM providers, et cetera. And we want to be able to make sure that you're able to orchestrate and bring all those things together in one. And finally, all this needs to be governed, right? So how do you know who's using what project, how's the output, or who's using what LLM, what are the prompts, what are the responses, how are you evaluating it, et cetera. We cover all the steps in that lifecycle from the build to the deploy, monitoring, redeployment, et cetera, to make sure that you have a very clear view as an organization of what you've built, what you've deployed, et cetera. The next one. So how do we do that? We really think about that in terms of, again, sitting across your data and AI infrastructure, both the dedicated pieces as well as sort of your enterprise things like Salesforce or Workday. Integrate those into a single place where you can develop analytics. So do your ETL, do your data preps, get things going. Also see insights from the data sort of automatically generated, so it's pushing to you. Also in your modeling, doing data science and machine learning, you can do model development, again, AutoML with visual tools or work in notebooks, work in code environments, what you're typically doing. But it's also on the operations side, right? What does it look like to deploy a model? What does it look like to maintain that model? How do you know how you're doing that? Not just at speed, but scaling that effectively across tens, hundreds, thousands of models, and doing it in a way where you're able to sort of maintain those and redeploy them as appropriate and know how they're performing. And finally, on the agent side, where obviously we're going to spend more of the time today, this is one of the newest aspects of the platform as we've been working into the generative AI space and agents. How do you build those agents and how do you control those agents, which is trickier than even on the model ops side of the ML stuff, and that's a big piece of what we're going to talk about here today, is that orchestration and control and making sure that the agents are doing what you want them to do.
Thanks, Connor. For today's discussion, we'll walk through why agents matter, the challenges of deploying them, 5 key categories for evaluation, how to go beyond benchmark, and then finish with Q&A. So businesses today are adopting agents because they promise speed, automation, intelligence across workflows. Let's start with what agents are. So the best way to think about them is a spectrum of maturity, from LLM chatbots to highly advanced autonomous systems. The biggest difference between Gen AI of 2024 and agents of 2025 is that agents can take actions to support complex workflows, not just answer a question. So that means they can plan tasks across multiple steps, call external tools and APIs, adjust their strategies in response to results, and deliver outcomes that map directly to business processes. At Dataiku, we've seen our customers across every industry and every use case using agents as sales assistants, maintenance schedulers, financial analysts, and even R&D assistants. But the challenge is the same across all of them, determining whether or not they're enterprise ready. Agents represent a really unique opportunity to transform businesses, but moving from a successful demo to reliable enterprise use is where most organizations stumble. If you've been experimenting with Gen AI agents for a while, you already know that success once doesn't guarantee success the next time. Let's explore why that is. So at first glance, agents might just seem like another piece of software. Both applications and agents serve end users within workflows, must meet enterprise standards for uptime, scalability, and compliance, and both require thoughtful design, testing, and governance. But where they diverge and differ is in how they work. So they differ in 2 important ways. Unlike deterministic software, agents generate plans on the fly, adopt mid-task, and may take multiple valid paths to success. Outputs can vary between runs, even with the same inputs, due to probabilistic reasoning. So as a result, binary pass-fail tests, code reviews that work with traditional software applications don't work exactly the same way with agents, because agents can fail in more than one way. Instead, you need to evaluate how well agents reason, adapt, and deliver consistent value against real-world constraints. In the worst cases, skipping agent-specific evaluation means risking wrong outputs, poor UX, PII leaks, bias, latency, cost overruns, and more. These aren't just corner cases, they're systematic, enterprise-wide risks that can really cause a lot of problems across the business.
Got to actually unmute myself. So, all right. So let's talk about, as we've talked about some of these different challenges. One of the key differences, as we talked about, from software versus agents, is how do you know an agent is doing a good job? And I want to sort of, before we talk about some of these specifics, the way that I really want to paint this, and especially when you're used to sort of thinking about software deployment, is that, when you're thinking about software deployment and regression testing and making sure all of that, the question really is, does the code function or does the code not function? If it functions and it does what it's supposed to do, then you're good. If it doesn't function, then you got a bug and you got to fix it. Unfortunately, in the agent space, it is not that simple, because an agent can still be functioning, but if it is still functioning, but is no longer performing and doing the right things, that's maybe even worse than it not working in the first place, right? You would rather that an agent is not working than it is making the wrong decisions, using the wrong data, saying the wrong thing to your customer or your employee, et cetera. And so this idea of performance evaluation of agents and making sure that we know they're good is really, really critical, because we don't want agents that are out there functioning, but functioning wrongly. So as we think about the 5 key areas to evaluate here, the first one is the task success and output quality, right? So did it work? So I was just talking about, but also did it give us the actual output that we wanted? Second one, user experience and business value. How do we make sure that the experience, again, on a customers or internally, is the way that we want it to be and that we're actually showing the ROI for the investment? Third piece is the reasoning and tool use. Agents can select from tools, can be autonomous in the way that they decide to work through a process. Are they doing that the most effective way? Does it use the same tool to answer the same question every time? Does it use different tools? Sometimes it might take more steps to come back to where it needs to go, right? So how do we understand the way that it's reasoning and evaluate that tool use? Next is the trust, safety, compliance. How well can we trust that? I already see a Q&A in the Q&A, a question about hallucination. How do we know that we can trust the response that's coming out of it? How do I know that I'm protecting my data, my customers' data, PII, all that type of stuff, and that I'm in compliance, especially with things like the EU AI Act, and as that evolves, and other countries, states here in the US, et cetera, start to put more regulations in place? How do we know that we're in compliance with all of those laws? And finally, what's the performance at scale? This is one of the most challenging things, especially because things don't always scale linearly, right? Where you do a demo and you do a demo of something across 1,000 or 1,000,000, instances to see how it does. But scaling from 1,000 to 100,000 to 1,000,000 to 100 million sometimes is not, 10 or 100 times the resources, it's 1,000 times the resources, or things start to break down. And so how do you make sure that you're being able to do this, not just on the test cases and on the build side, but that you still have that performance? You're not running into issues with latency. You're not running into other issues there. So these are the 5 things that we're going to talk through here. I'll give an example of each of these and then talk through some of the ways that we help to mitigate that. So the first one, on task success and output quality. So let's think about like an example of when an agent does the wrong thing and we have inconsistent or unreliable results. So a simple example here, relatively speaking, is we've built an agent that's able to reset a user's account password, right? Rather than it being a very specific rules-based, click this, you get an email, there could be different ways. Maybe there's 2-factor authentication in it. Maybe they're using an external something, whatever. There's different ways that this can be solved depending on the actual instance of that customer. And so we want to make sure that the agent can do that. And so we test it. It works 9 out of 10 times. But sometimes it does extra things along the way that it really didn't need to do. It asks the user for something. It makes them do the same thing twice, jumps through hoops. I'm sure we've all had that in the real world, trying to do something like resetting a password. I had one just yesterday that took me like 8 tries to figure out how to get in. So I doubt they had an agent behind the scenes on that one. But this happens already. The whole point of an agent is that we're getting around those things. We're able to sort of do it contextually. So we don't want an agent to create confusion, to take longer to resolve the customer's issue, et cetera. So how do we mitigate that? So the key piece of like why we care that this needs to happen is that we know that we're getting the right output and we understand that it's functioning. So what do we need to evaluate? We really need to evaluate to ensure that outputs are consistently accurate, they're reliable, and they meet what we're expecting from a business perspective. So that's what we really want to be able to do here to evaluate that. And how do we do that? There are different things that we need to be able to track along the way. The first one is really just, did it provide an answer, right? Like, did the agent make its way all the way through? This is that sort of classic software testing, like, did the code function or did it not? If I didn't get an answer, then I know the agent's not working. But I also need to then, secondly, have a way that I'm evaluating output correctness, both from a testing perspective, but also in the real world, when things are out there, how am I testing, making sure that this agent is continually giving the right results? Am I just checking random sample answers? Am I checking every answer? There's different ways to be able to do that. And there are different reasons to use things that are maybe a little more heavy-handed, things like LLM as a judge that's going to check every response versus doing random sampling and having a human look at it, however you want to do it. But you have to be checking that output correctness to make sure that not only did I get that task was completed or the goal was completed, but that it was completed correctly. The other piece is instruction adherence. Did the agent work within the bounds that you've given it? Did it access, maybe it has tools And there's some tools, think about an internal agent that, has access to HR data to be able to answer certain questions for HR specific reasons, but it's constrained to that of saying, hey, we only want you to use this data for these particular instances. Or you could use this data, but you can't actually give personnel specific information out or something like that. Is it following those instructions, or does it go rogue and share salary information from one person to another or something like that, right? And finally, and this is a theme we'll probably come back to a bunch of times across the day, is that idea of the expert in the loop. We are, as we build agents, really thinking about building, again, things, AI products that can act autonomously, use complicated reasoning, use tools to solve problems. This is not something that we can do without having the right people in the loop. One of the best ways that I've heard this phrase, and probably many of you have heard this, is thinking about an agent as an intern or a junior grade employee, somebody that's new and entry level. You can set them tasks, you can give them access to data or tools or whatever, but as a manager or a senior person or whatever, like, you are that expert in the loop, checking their work, making sure things are happening. This is a really important thing to do. And again, this can happen both from a testing and a build perspective, but it really needs to happen some way that you're evaluating stuff to say, hey, I want to put a certain number of decisions past a human, past an expert who would normally have been doing this task, or is that person who does the harder ones, to say, am I getting the right results here or not? And this is how you obviously then can continue to refine and improve that agent, but knowing how it's doing versus it's not is the biggest challenge there. So that's our first one. The second one, again, something going around here, poor user satisfaction. So we've got an internal HR assistant agent that helps you find benefits information. Maybe it gets the right answer, but it asks question after question after question to that employee before it gets that right response back up. That's not really helpful. The whole idea of having that agent is that I don't have to go in and figure out the if-thens to get to the right document. Also, back to the previous thing where I was talking about, does it have access to the HR system, to your Workday or whatever your ERP is, to be able to say, okay, I've typed in a question here. What country do I live in, right? What state do I live in? What part of the company am I in? What program am I under, et cetera. If it has to ask me that, I go in and I say, like, hey, I want to know if I have coverage for this specific medical thing. And it says, okay, do you live in the Americas or Europe or Asia? And then it says, which country do you live in, right? Like, that's data that should be there. Shouldn't have to go back and forth with the agent on that. And so this is where you really want to make sure that you're understanding how the agent is working through the process, and is it doing it in a way that's going to be better or worse than somebody just emailing HR. So let's talk about how do we evaluate that. So what do we need to do? We have to ensure an agent is delivering a smooth, intuitive user journey that drives adoption and ROI. This is a really interesting challenge to me, and something that hits home for me, is that we ask a lot of data scientists, AI engineers, the people who are building and creating these things. And they have degrees in math or computer science, they have experience in the whatever domain, they're good at working with the data, et cetera. But building a UX and testing user experience, or building a UI and testing user experience, whatever, that's not always, and often not, in the sort of background and domain experience of a data scientist or an AI engineer who is building these agents. And so we need to be really thoughtful about starting from what is the UI? What is that user journey? How are we making sure that the agent is delivering? And this extends into some of the other modeling things that we do from a data science perspective. And so how do we measure that? Again, we want to evaluate this to make sure we know that it's working. First one, ask for user satisfaction, right? Whether it's you're doing just customer sat of, did this answer your question, yes or no? 1 through 5, do an NPS score, the 0 to 10, how likely are you recommending my HR internal chatbot? However you want to do it, track that user satisfaction, right? Find where you're getting bad results so that you can dig and understand it. The second thing is checking via clarity and tone, right? Again, this is asking using an LLM to look at all the responses that it's getting. Is the agent providing the response in the way that you want it to? How did you train that agent? More specifically, what did you give it as sort of examples of, okay, back to our HR example, I've got, I would assume, an HR email box or some sort of contact system that should have lots of history of HR people interacting with somebody to answer these questions. Did I use that to help train the agent so that when the agent is interacting with people, it sounds like somebody from HR? Whether that's a good or a bad thing, I don't know, but whatever, we want to be consistent, right? Or we have a target for it. We want to know what that is. This is way more important when we're thinking about customer satisfaction agents that are working outside interacting with our customers. Do we want to make sure that that person's experience interacting with the agent is analogous to that interaction that they would have with one of our employees? Third is engagement and adoption. This can be a real challenge and has been a real challenge in the data science spaces. Rolling out tools, especially tools that are outside of somebody's existing workflow, do they choose to use it or not? Our HR example, okay, there's a HR chatbot. If I've gone to it a couple of times and it couldn't answer the question, or it did answer the question, but it took me 20 minutes of back and forth with an agent, I'm just going to email HR from now on, right? So actually then sort of look at, did this shift the volume of the contacts and actually satisfy those? Or when we're thinking about, again, that sort of customer service agent, how often does the customer service agent, if that's our first line of what a customer interacts with, actually solve the question, right? Do they get it right 50% of the time, 80% of the time, or 5% of the time, right? Really see how that's going. Last piece, or next piece here, is the conversation quality. This is related to that clarity and tone, but again, really sort of understanding the dialogue of the back and forth. And this is where you start to marry that against the previous one and looking at what tools did it use? How did it answer that? Did it answer the question that was clearly asked the first time? Or did the person have to sort of basically restate their prompt 3, 4, 5 times to really help the agent actually understand it? That's the thing so it is, again, it's not just that clarity in tone, but it's also, is the agent reacting to the data that it's receiving the right way? Is it answering things succinctly? Is it straightforward? All that type of stuff. And then, again, our recurring theme of the expert in the loop. If I have an HR chatbot like this, are HR people doing that? How are we looking at that? How are we looking at the results on this? I see that, one of the comments in there around these being qualitative versus quantitative. There is a mixture of both of those, right? Things like user satisfaction is absolutely quantitative. Things like engagement and adoption, looking at the percentage of how much people are using these, that is very much quantitative. On the clarity and tone and conversation quality, some of this comes into just our general LLM evaluation frameworks of the correct answer. Is this the tone that we're getting and stuff? So a couple of those latter ones are definitely a little bit squishier metrics, but there are ways to make those quantitative. So it's a great comment that went on. All right, let's go to our third one here. So next, once again, what's happening? Okay, we have flawed reasoning or tool use. So in this case, we have a financial analysis agent, and it's asked to prepare a revenue forecast. But actually using a visualization tool, reporting an API, how is it? It's automatically providing that output and into a dashboard or spreadsheet or something like that. So it calls the API, but in this case, it calls it 3 times, asking, multiple, whether it's the same or sort of overlapping queries, and then doesn't aggregate those results back together appropriately. So then it makes a pretty report, but that report contains duplicate numbers. So here the tool is functioning, back to where I started with. I asked a question, or I asked it to prepare this revenue forecast. I get a dashboard back. I get a visualization of it. It's got the data in there. now I should be able to trust that, right? So it's functioning, but in this case, it didn't properly aggregate those results that it got from calling the API to get that data. And then the answer that it's now giving me is wrong, which is, again, to me, arguably worse than it just not providing it at all, right? I would rather be able to, if it works and then I can trust it. If it's not going to work, then I can go pull the numbers and I can go do this myself, right? That's a better scenario than having to either then, as a human, figure out were these answers correct, or have to go redo the work or redo it multiple times. So how do we set this up to make sure that we understand the reasoning and that the tool use is there? So we need to ensure that the steps are efficient, they're transparent, and they are verifiable from what was asked through to the outcome. So the first one is understanding the plan and intent accuracy. This is where you really start to open the hood of the agent and look at the stack trace, understand what steps it took, because you can see here was the prompt that came to that agent. You can see then, you can pull up the agent reasoning that says, this prompt is asking for this, and now I'm going to send it to that tool, and then this whatever. You can see what that plan looks like. This is where you can especially start to aggregate questions that are similar, understand, and some of this, there is a big aspect of expert in the loop, as always here, but this can be quantified to say, okay, I had 500 queries that were all about the same topic. And of those 500 queries or prompts about that same topic, I saw 80% of them went this path, this tool, then response, and that was accurate. 10% of them took a couple other stops and then went back through the same thing. And then the last ones maybe, somehow are just giving me wrong answers, etc. So you have to be thinking about checking these as they're going. You can do it on the fly. You can set these metrics up to track, and you can even have, if you really want, as an LLM as a judge, something in the middle to sort of do this. But that is a part of the scaling side. The tool call accuracy is part of it, right? How do I know which tool it pulled in? If the plan said, call this tool, this tool, this tool, were those the tools that it actually did? That's one piece. Second piece is, this is, the plan, but the plan was wrong. And, I need to understand those different things. The trajectory efficiency, this is really in that sort of, is it doing it in the simplest path possible, right? Can this be satisfied? I'm asking questions about revenue from last quarter. There's a text to SQL thing that's really just going to pull it up from, our data warehouse and pull that. There are things that we can absolutely put in checks in place to say, even before the response goes out, but maybe while it's, maybe it's after the fact or it's aggregate, to say, there's a certain pattern type, a question about revenue or about historical revenue should always be answered via this tool that's looking at actual retrospective data. Something that's asking about revenue forecast, like our example in the previous slide, that should be then pulling up my forecast model, whatever my ML or my forecast that out there is. And so anytime somebody, you can even just do this by a keyword, right? Like every prompt that asks for a forecast, did it use that tool right away? Did it have to go back and forth, etc.? Next piece here is error handling. This is a big one, especially in terms of in production. How are you doing the error handling? If the agent gets a bad result, right? Or gets a null result, it's calling another LLM to, pull data out of the RAG, and it comes back and just says, not enough data, or it's inconclusive. How is it responding with that? If it pulls those things together, do you have a way that it's checking things to understand, in this where we talked about the forecast stuff, do you have a checkpoint at the back to sort of say, hey, does this match some specific data set or something along those lines? How is it handling the error? Does it just spit out the answer? Does it come back and say, I'm not getting a good one, I'm going to rerun, I'm going to go back through the process again? Does that happen 1 time, 2 times, 3 times? can you have an agent get stuck in an infinite loop of, it hits an error and it's just going to keep going back through? You have to be thinking about, proactively thinking about the ways we want it to handle errors, especially for certain types of queries, but then also how are we going to track these and make sure that things, don't run amok or, use a whole ton of tokens or something like that because it keeps running the same query over and over again. And finally, expert in the loop. I'm a big fan of agents having at least some level of almost like A/B testing, where we're throwing some that would be handled by the agent to one of our experts and using that as part of our validation set as well. But either way, whether we're looking at aggregate results afterwards, where they're testing in process, making sure that we've got an expert that is part of that process that can look at what's going on, can evaluate those results, incredibly important no matter how you do this. All right, let's go on to our fourth one. So what about when it goes wrong around trust, safety, and compliance? So we have a customer support agent saying, can you confirm my last order? Here, instead of just giving it or giving the status of the order, it displays out an address and credit card details, something like that. So sure, maybe it also got the answer and it said, here's your order, Mr. Customer, et cetera, et cetera, et cetera. But we've now exposed PII that maybe in this case, we're exposing the PII to the customer themselves. And so it, could be worse, but there's plenty of instances where we could be displaying PII externally, or if we've got this, set up as an API. This provides reputational risk. If you're in a regulated industry, this is a compliance violation. If you're under GDPR or things like that, there are additional things. So there's a lot of risks here if we get, again, that trust of the response or the safety and compliance wrong. How do we check for that? So we have to ensure that agents are behaving within safe, data, ethical, regulatory boundaries, and that we can audit all of this. That is a huge component of it. Again, back to this, the questions come a couple of times is, how much can we do this versus testing? How much can this actually happen in production when we have stuff that's live? You have to set up the appropriate guardrails, filters, auditability to be able to look at both results in aggregate and results in individual and check for things like that. So putting on a toxicity filter. We've all seen the examples of, LLMs going rogue, sometimes deliberately because people jailbroke them, but often enough where they just sort of do it themselves. We need to have that filter to make sure that the LLM is responding appropriately. And this should be something that's on, again, every single result can be going through a toxicity filter. Hallucination and groundedness. There's a question in the thing earlier. Hallucination can be very tricky. If we go back to that, the analogy of thinking of these as an intern or an entry-level employee, sometimes the answer just doesn't quite come out right. It's not grounded in reality, and that's part of having the expert in the loop there, but evaluating those things to say, okay, sometimes it's just as simple as having LLM as a judge in the process. You ask a question, it gets a response. Before the response comes back to you, you run it through another LLM that says, does this answer actually sound right? And sometimes you can catch things there. Hallucination is a still really tricky one. This requires a lot of the build up front, right? How are we testing before we build it? But we do need to make sure that we're checking on the back end. Policy adherence. Is this following our company policies, our data use policies, et cetera? How do I check for those? Again, you can put something that is a specific check to say, hey, this is a guardrail. We have a policy around, how use of a specific data set. And, I want to check, did this agent use data from a data set that was restricted in policy for which it could be used? That, again, these are then sort of custom things that you're building. These aren't, just an API that you can call necessarily, but building these guardrails. Prompt injection resistance, though, is one. There's a lot of tools out there that are making it easier for us to not let customers or users jailbreak the guardrails that we've put around it. So how do you monitor for prompt injection? How do you put prompt injection detection in place? What is the handling for that, right? Do you just throw a null result or an error result, or do you shut down that interaction with that user entirely? Fairness and bias checks. This is especially important when we're thinking about what we are getting back from, without getting back what the sort of, whether it's a subpopulation analysis, some sort of responsible AI type thinking in there, putting those in. Am I aggregating results and making sure that my results are consistent across responses to people of different genders, to people of different backgrounds, to people of different levels of seniority within my company, et cetera? Those should be checked. Often that's done a little bit more sort of in aggregate and in batch than on the fly, but there certainly can be things to look at, put where there are things that have gone wrong. As you've looked at it, you can put those in place. The auditability side. How do I look at what has happened? How do I look at every choice that an agent has made? How do I look at every choice a person made with that agent? How am I able to check those? The question in the chat, speaks directly to this, of that idea of white or sort of open versus black box systems. I'm extremely personally and I would say Dataiku philosophically is always a fan of the open box and the white box sort of thing, because if you can't look under the hood to understand what prompts were sent, how an agent acted, you're then really unable to do that with the expert in the loop, as we talked about, or things like that. This is very much that auditability. Can I look at every query? Can I look at every response? Can I look at every decision used afterwards? This really does need to be open. It's one of the concerns I especially have with off-the-shelf agents that companies are coming out with, at this point in time, is if you can't evaluate for yourself how that is doing, and you're completely basically sort of offloading that validation to the provider of that agent, that makes me really nervous. An example of something like that going the way that you don't want it to do was, there was a startup, this was pre-agent, but very heavy sort of in the ML space a few years ago. That was, and some of you probably will know this example when I talk about it, but it was a HR evaluation tool that was used in the recruiting process to help screen. And it was a fairly closed system, right? It was just an API, you put it in, you got a response back, hire this person, don't, or, interview this person, don't interview this person, etc. And they had a change in their data from something upstream from them that turned their results very discriminatory, let's put it that way. And there was no way to understand that was happening. There was no way for those users to be able to go in and say, what is the reasoning here? What is the response rate? What is the variable or the tool that's giving me this result? If you can't go in and look at, and this can be hard, again, this is a scale challenge, which we'll talk about in the next one. Okay, am I doing this? Am I having an agent being called 100 times a day? Evaluating that, as long as it's in there, I can have an expert check all 100. I can do automated checking, and I can do et cetera. Start talking about 1,000, 10,000, a million queries a day. How you then do that auditability becomes a bigger challenge, and you need to sort of, again, talked about random sampling or different ways that you can solve that auditability. But if the system is a closed system, if it's a black box, then you can't audit anything and you can't do it at all. So that's a prerequisite for me, is very much that these systems are as open as possible. All right, finally, number 5, let's talk about agents failing to scale. So we've built a supply chain planning agent. It is supposed to generate a daily production schedule for 50 factories. So we test it, we build it, we pilot it out where it's looking at, 5 plants. And it does plan those. It meets the demand forecasts that we have coming in. It effectively develops a deployment schedule, or production schedule that will actually meet those. But we roll it out and we go from 5 to 50, and we've 10x'd the response or the queries that are coming into it to be able to do this. And suddenly we have a massive latency issue. And so we're having a lot of, it's hitting the same data multiple times. So maybe we're, asking too much of the data warehouse underneath to be able to do it. Or I have to call the demand forecast model. And if I call the demand forecast model 10,000 times in a morning or something, suddenly, that chokes somewhere along the way. This then, can result in API rate limits that are causing like incomplete schedules. So now suddenly I'm, underproducing somewhere, or I'm underproducing a certain product and I'm overproducing somewhere else because I didn't get the forecast information the way that I needed to, or whatever that data point needs to look at. So you get, this is, I think, pretty evident, right? Like how this stuff can go wrong, and the scaling can happen. It can be a challenge in many different parts of the process, right? It's not necessarily the agent itself that's going to fail to schedule. It could be or fail to scale, excuse me. It could be the tools that it's accessing underneath or something like that. So how do we make sure that we are able to sort of scale effectively? So ensuring that we're meeting enterprise grade requirements under real world workloads is easy to say, hard to do. This tends to be, something that you have to be really, really aggressive in testing before you really start to roll agents out. So measuring something like latency and response time. Yes, of course, as you're piloting or you're testing and building a tool, you do that. But before you go live with it from those 5 to those 50, run it in parallel with an existing process, or just run it for 1 month and see how it goes before you start to do those rollouts, but do it as scale. No, you shouldn't be trusting the LLM for the demand forecast. LLMs can access demand forecasts. The LLM shouldn't be providing the forecast. So that is in fact scary. Another piece we want to look at is the token and cost efficiency. This is another piece that you can really sort of have challenges for. We had a customer who built in the airline industry a tool for gate agents that sort of help improve loading times, and tested it out and actually saw really good results on what it could do for their interactions with their customers. But when they looked at scaling that to thousands of gate agents at any given point in time, the cost of doing that, it wasn't there, right? And so it did show positive results and it was doing what they wanted it to do. But once they tested the scaling on it, how much they would need to spend from a tokenization perspective really made it so that it wasn't an effective way to be able to go and do those things. And again, test it during your test phase, but run it at scale for a small amount of time. Use things like cost guardrails on top of it that will actually say, okay, run this query. We've run it over 1,000 records or 5 plants or whatever it is. Now we want to run it over the whole data set and put something in there that says, if this is going to cost X tokens more than we expected it to, like just cancel it, like don't even run it at all, or test it. So again, you really need to be looking for these things, both in that test phase, but you have to start to, or both in the development phase, but very much in that test phase before you start rolling these out at scale. The tool API overhead, right? I talked about that in terms of that accessing a demand forecast or something like that. How much am I calling a specific tool? How much am I calling a specific API? Are those APIs developed to be able to do that? If I have an API that was built for a system that is being used by humans that are manually inputting data, calling the API, something like that, is that being called right now just 200 or 300 times a day? Or something scale, and that's what it's been built for from a latency and a performance perspective. An agent can suddenly 10x that, literally within the first hour. So like, how do we ensure that those tools that we're giving it, are they built for the types of scale that we may actually require of them? Uptime and scalability. This is the sort of classic IT challenge of, especially things that are customer facing. How do we guarantee uptime? Do we have redundancy of an agent if an agent fails, or if those tools fail, how are we going to be able to do that? And are those underlying tools, are those agents, are they built to be horizontally scalable or vertically scalable in a way that we have, failover and horizontal deployment or things like that to be able to make sure that we're able to do those things like high availability and stuff. If you have to really talk in seriousness about high availability of an agent yet, but it's a definite thing that will be there as we start to build more and more business critical agents. Last piece here on the scale is the error rate. As we do more and more and more, the impetus to make sure that we look at that error rate and that is scaling, either declining with scale or staying the same. If we've looked at some of these earlier evaluation pieces and we looked at, did it fail? Did it fail 1% of the time? Did it fail 0.1% of the time? Did it fail 0.01% of the time? If we now scale that out, does that scale linearly and it stays at that 0.1%? Or does it now suddenly start failing 1% of the time? Or is it failing, at those points in time? Or again, could be functioning, but giving me the wrong results. However we're looking at that, we have to be really cognizant of what that error rate looks like. How are we doing error handling? Does it just send it to a human to provide the response, et cetera? But are those happening so that we're not going to overwhelm the system with now suddenly, something that we thought would have a 1% error rate has a 20% error rate, and we don't have the people in place to be able to sort of deal with that. Finally, expert in the loop. This is an interesting one because this often becomes an expert as much on the IT side of the house as on the business side of the house. Most of the things we've talked about so far have been really, I'd say, like business experts are the ones thinking through this. A lot of these things, though, really are now, who on the AI team, the engineering team, or the DevOps team, or whoever, you have that's responsible for this, how are they handling things and making sure that they're, performing effectively across all of these different metrics? All right, so let's tie this up. We'll switch to some Q&A here in a second. So what does enterprise readiness look like beyond just sort of setting benchmarks and looking at some of these things? So there's, our key takeaways here. So we talked about these 5 different areas that you need to be able to evaluate: task success and output quality, user experience and business value, reasoning and tool use, trust, safety, and compliance, and performance at scale. These are all, these aren't 5 options. These are things that you need to be able to do across all of your agents. And so how do you do that as an enterprise to be able to sort of do this at scale across multiple agents and hit all of these different areas? So there is a sort of hybrid approach. There are some IT functionalities in here. There's some business functions in here. There's some things that has to happen beforehand. There's some things that need to happen after you've deployed. There's things that need to happen in production. So when you think about from a phase perspective, you have the testing. Did we do all the realistic things while we were building it? Deterministic test suites to test for some of the things we were talking about with a human looking at that. Repeatable scoring that's tied to some sort of a promotion gate or a catalog or something like that, to repeatedly say, does this match the threshold that we need it to be? Whether it's an error rate is low enough, a accuracy rate is high enough, et cetera. We have very specifically, we're testing that repeatedly throughout the build phase to make sure that we're not progressing until we've hit what we want those to look like. Before we go and launch it, we should be looking at deterministic and open-ended scenarios, right? The deterministic ones, the sort of our testing stuff is really, I have examples of this customer interaction and I'm testing to see how it's done and I'm pushing it forward. But I need to be able to also ask some more complicated questions of it before we start to launch it. And, that's where then I don't necessarily have what the right answer is. I have to have people who are evaluating those. Doing regression tests on every change. Again, the regression test isn't just, does this code function? Does this agent function and provide me a response? But I'm evaluating those regression tests against these different things that we've talked about. And then do pilot comparisons, A/B testing against baselines, against humans, against old models. This can be an interesting way in terms of looking at, a vended solution versus something internal, like actually doing those things. And finally, there's still evaluation that has to happen in production on the fly. Some of it can be automated in its metrics and it's things that we talked about earlier that are very quantitative. Some of these are qualitative and we need to have expert judgment for nuanced behavior, as it says here. We have to mix both of those things that we can quantify, we're looking at quantitatively. Ideally, either like at runtime or shortly thereafter, depending on the sensitivity of those, but we need to be able to hit those. And then we have to have continuous monitoring to where it starts to go off the rails. Like it can't be, we're looking at this at the end of every month or the end of, every quarter or something like that. Like this really has to have a continuous monitoring so that when something starts to go awry, we're able to react to that as quickly as possible. And as has come up repeatedly throughout this, experts in the loop are crucial for you to be able to do this successfully. So let's go to the next slide. And then here we think about this, like your subject matter experts are critical to all of those phases we talked about on that previous screen. How do I develop this agent in a way and validate that it's doing it before it sees the light of day? This has to be you sort of validated through the people who know how to do what we want this agent to do. They can look at the risk. They can look at, benchmarking, what is the 1% error rate matter? Is 5% acceptable? Is 0.5% too high? All those things. Also, this is really critical, especially in terms of that adoption stuff we talked about earlier of building trust. If your experts, your SMEs, your really trusted people in the business don't believe in the agents, that's going to be very hard for you to get that adoption for people to be able to use them. Conversely, when the experts are involved with it, they help to build it, they're helping to champion it on your behalf in the business with their peers, with their subordinates. That's what will really help you sort of do that adoption very quickly. Awesome. All right. So before we throw to the Q&A, a couple things, of things for if you don't know Dataiku at all, you're welcome to scan the top QR code there. There's a quick 3-minute video demo that shows how Dataiku does analytics models and AI agents all in one platform. We also have another webinar coming up soon around designing scalable governance programs in a way that support and enhance your business and innovation rather than restrict it. So we'll leave that up for a second, and then we will switch to some Q&A. There you
go. Awesome. So let's go through some of the Q&A that wasn't already answered during the presentation. So one question was, how are MCP context engineering reducing the need for complex evals? So in this case, MCP and context engineering reduce evaluation complexity by constraining how agents operate. So MCP standardizes tool use with predictable, auditable interfaces, cuts down on unsafe or inconsistent behaviors, and good context engineering really grounds agents in structured prompts and trusted data. So that helps to reduce hallucinations and variability. They can shrink the risk surface, so evaluations focus less on catching errors and more on measuring business value and user experience. Someone else asked, is there any inference to see intent accuracy like LLM as a judge?
You can use stuff like LLM as a judge. Also do this from some of that sort of actual like human expert testing, right? So some of it you can do via LLMs. I'm always cautious to sort of say like, hey, you can't rely over much on LLM as a judge, both from a cost perspective, actually more from a cost perspective than as an accuracy perspective. But doing that sort of this honestly is really one of the things that I think will be really interesting and tricky as we think about over time evaluating how an agent does sort of in simple metrics, because we need to move our next layer beyond just did the agent provide the answer that we expected in a reasonable fashion. A lot of stuff we talked about too here is, did the resulting decision or action, especially if it's an agent that's designed for a person to interact with, actually, then do what we think the right next step is. Did they do what the agent suggested? Did they provide that answer to the customer? Did they run the forecast that the agent gave them, et cetera? How are we actually tracking the like end business results? And so that context from sort of like objective tracking will over time go from, yes, we can use things either again, experts in the loop sometimes ahead of the fact, but usually like after the fact. Did this question get answered in the way the person that was asking it? We can use LLM as a judge to do that to some extent, but over time, we'll really need to start shifting that to not just did the agent give the person the result that we would expect to based on the context, but did the actual action and business result come out of it that initial sort of context, the customer query should have resulted in this happening, even if the agent, gave the right answer, did the person do the right thing with it?
Someone else asked, is it safe to use LLMs as evaluators for vibe and tone and automate that over domain experts? So using LLM as a judge, you can definitely automate like baseline scoring for tone and vibe and like route edge cases and high risk outputs to subject matter experts or experts in the loop for validation. You'll kind of want to continuously compare LLM judgments against SME judgments to calibrate and tune the evaluator. So it's definitely safe to use LLMs as a judge, but not fully to replace domain experts. And I think that kind of ties into some of the other Q&A we have here around experts in the loop. So someone asked, how do you balance the amount of experts in the loop requirements so SMEs aren't spending all of their time babysitting agents?
There's not a simple answer to that one. Great question. I definitely get where you're coming from. I think part of what you need to look at is sort of like the criticality of the agent. Not all agents are created equal, and not all agents have the sort of potential to either do good or bad things in the same way. And so really being thoughtful and cognizant about, okay, I'm rolling out 3 agents in my sales operations team. This one will be working, very autonomously and providing stuff straight to a customer versus this one is going to provide something to my salesperson and, or this one's going to provide a dashboard or something like that. Like those don't all have an equal level of need and I guess criticality and danger in them going wrong. And so being judicious about what does the right sort of tempo timeline look like for SMEs there. Second piece that I'd say, and this is this challenge goes beyond agents, but I think it's important, is that we need to also be thinking about that expert pool and not having the same experts every time. And so we also need to think about that in terms of okay, am I asking the same person to babysit these 3 or 4 agents? Am I asking a team of people to share that responsibility and really managing it? But I'd say it's an interesting thing that we'll curious to see how this evolves in the business world, right? Is, how will you evaluate your employees or your experts' use of agents, right? So did we roll, and this, I guess, both then tells us how an employee is doing, but also tells us how an agent doing. If I rolled out an agent that has an employee spending all of their, or a team spending all of their time babysitting the agent, did it speed up anything? Are they able to sort of do their job, or is it taking off their place some of the lower value work and allowing them to do something different? That's something that I think is both important for us to, as we encourage employees to effectively use AI, that we are tracking their usage of it and how they interact with agents, et cetera. But that also then is a part of the performance evaluation of the agents themselves to make sure that agents aren't just being a drain on our people.
Okay, and then let's get a last question here as we're in our last minute. So another question on humans in the loop. So Derek asked, experts in the loop is key, but I often see a reluctance from experts, even outright lack of cooperation due to concerns they're training their replacement. Any thoughts on the human side of this and getting buy-in?
Not to be like overly tongue in cheek, but like it's a valid concern for people, right? Like we are seeing examples of that. A big part of that does come down to how your organization is handling rolling out things like this. When you roll out an AI tool that, I've seen this, I guess, a couple of times on in the startup space recently of, oh, we bought an agent that does our business development representative, right? Like outbound sales type stuff. And we fired the entire team. If you did that, and then you go to a salesperson to say, hey, we're looking at an AI agent that'll do these things, I'm that salesperson. There's no way that I want to be able to help with it, right? So like, there is no better answer here into sort of the proof is in your actions as you do these things. The skepticality is completely valid and understood, obviously. And so it's through how you roll these things out and how you're communicating it, I think is really where it's going to happen. Obviously, on the first one or the first couple, there can be a dance and sort of finding those right people, because if they are really resistant, then you don't want them to be part of the project. And so finding the right experts to help out is important, especially early on. But the only way to really truly solve that is how you as an organization roll these things out. And are you using these as ways to make departments more efficient, to be able to do more advanced work, or are you using it to replace people? Everybody will see how you're acting there.
Thank you, Connor. So feel free to contact us via email, reach out to your account manager. In the next couple of months, we'll be releasing a lot of fun and exciting product launches that will help with evaluation in Dataiku, as well as managing the agentic lifecycle. So stay tuned. We'll have more webinars as well on how to do evaluations in Dataiku and using Dataiku tools, as well as more about resources and content coming out on integrating humans and experts in the agentic lifecycle. So please keep an eye out for those, and I hope that everyone has a great day.
Thanks everybody for the great interactions. Appreciate all the questions and chat. Have a good day.